Hi, good afternoon. I'm Todd Bacastow with Maxar, and it's my pleasure to be here today to talk about SpaceNet. We're going to talk about SpaceNet 8 results and announce some more details for SpaceNet 9. So thanks to Eddie and for the planning committee for the opportunity to be here again this year. This has become one of, as Eddie alluded to, one of the recurring presentations. So we're really excited to share this year's updates with you as well.
Go ahead.
So as we're thinking about how SpaceNet evolves and any of the challenges that we have upcoming, we always try to take a step back and think about, well, why we're doing what we're doing and how this can have an impact. One of the areas that we're focused right now is around the ability to improve data wrangling capabilities that can reduce sense-making timeframes. We think that artificial intelligence, specifically computer vision capabilities, have a lot of potential to improve the alignment of multi-source data needed for downstream analytics. And this is particularly important in with open data or disaster response type scenarios when you can't necessarily predict what type of data you'll have in any given scenario. For those that aren't familiar with SpaceNet, or those maybe that have heard of it, just a brief background, SpaceNet is a collaboration aimed to accelerate open source machine learning applied specifically for geospatial uses. This project was founded by Imagery Labs, Cosmic Works Group, as well as Maxar Technologies in August of 2016. Leadership of the project was transitioned to Maxar in April of 2021, and today I'm very pleased to share our current partners that collaborate with us on this project, including AWS, IEEE GRSS, Topcoder, Oak Ridge National Laboratory, the Open Geospatial Consortium, and most recently, Umbra. The four pillars of SpaceNet have been consistent from the beginning. We saw a need to help provide labeled training data sets specifically for satellite imagery. We run a series of prize challenges to help accelerate innovation in this space. The winning algorithms from the challenges are open sourced, and then the evaluation metrics used in those challenges are also published. The data sets and the algorithms are, the data sets are available before, during, and after the challenge, and then the algorithms persist after as well. And there's this number of publications that we publish around each challenge, including blog posts, as well as research papers as well that are available for the broader community. From the beginning, we started pretty simple around mapping problems that we saw across the community, particularly around foundational mapping. So we started with building footprints, we added geographic diversity, we added then roads and additional complexity as we progressed from SpaceNets 1 through 7. Today I'm going to talk more about SpaceNet 8 and then where we're going with SpaceNet 9. SpaceNet 8 was concluded in August of 2022. The objective was to identify flooded buildings and roads from pre- and post-event imagery. And there's a couple aspects that were novel. This was the first challenge that we actually had multiple features that had to be identified. So not just buildings or roads, but buildings and roads. So that was unique. It was also the first challenge that took into account pre- and post-event imagery. And then it also took into account attribution of those features in the post-event imagery. So it was the first time that we had done that in a SpaceNet challenge. The competitors also had to handle realistic dataset noise, including image alignment, cloud cover, and missing regions that you typically find when you're working with this type of data. You can see some of the amount of data that was released as well as the prize amounts. To give you a sense of what some of the outputs look like, you can see our reference sample, as well as then the outputs from the top 5 winners across a selected area, as well as then, so this is for buildings and roads, and then the attribution. So the key takeaways from the challenge, we talked a little bit about this, the preliminary results of FEDGEODAY last year, but this year we have some broader analysis to share. So about 1.5 improvement over the baseline, and there was, some of the techniques that were used, there was pre-processing of the data, there was actually data used from prior challenges as well, on ensembles of neural networks, and rules-based post-processing to look at areas that wouldn't make sense for flooding. So happy to share a couple more details on SpaceNet 9, which is launching this winter. Our goal is to advance pre-processing techniques for computer vision. Specifically, this challenge will focus on the alignment of tie points for optical imagery and SAR data. You can see an example here, and it looks at tie points such as corners of buildings, road intersections. And we think this is important for additional downstream analytics for object identification. Here's the timeline that we're working on for SpaceNet 9. Our goal is to launch this winter and then announce the winners in Q1 of 2024. So really excited about this challenge, incorporating both electro-optical and SAR data. And for more information, please come talk to me afterwards. Also, you can check out our SpaceNet.ai website, as well as the open data repositories and our social media platforms. So thank you very much, and I appreciate the opportunity.